is Miley Ryan, and today my partner and I, Heaven, we're going to be showing you hypothesis testing, and so I'll be explaining the Z step, and she'll be giving you an example for T-scores. And so with the first steps, so there's 5 steps total with hypothesis testing. So the first one, we're going to state the null and alternative hypothesis. Second, we're going to choose our level of significance. Third, critical values. Fourth, we're going to be finding our statistics. So in my case, I'll find the Z, and in hers, she'll find T. And then lastly, we'll draw our conclusions. So with my example for a Z test, I'll read it out loud. So blood glucose levels for obese patients have a mean of 100 with a standard deviation of 15. A researcher thinks that a diet high in raw cornstarch will have a positive or negative effect on blood glucose levels. A sample of 30 patients who have tried the raw cornstarch diet have a mean glucose level of 140. So they're asking us to state the hypothesis that the raw cornstarch had an effect. So first we need to identify, as it's stated above, first number 1, state the null and alternative hypothesis. So I'll do that in blue just to stay color coordinated. So for the beginning, the first sentence, blood glucose levels for obese patients have a mean of 100. This will be our null hypothesis. So have a mean that means equal sign, and anytime you have an equal sign, that's your null hypothesis. So I'll underline this sentence as our null hypothesis, and I'll write it down below. So null is mu equals 100. And then second, I'll identify our alternative hypothesis. So a researcher thinks that a diet high in raw cornstarch will have a positive or negative effect on blood glucose. This is our alternative. So it said positive or negative. So this means that we're going to have greater than or equal to. So our alternative will be mu, or actually, let me write it out like this. So I'll put 100 and then mu in between, or, okay. So mu is either less than 100 or greater than 100. Okay, so now on to step number 2, we're going to choose our level of significance. So because it's not explicitly stated in the problem, we can assume that the level of significance is going to be equal to 0.0. Okay, so now we're on to step 3. We're going to find our critical values, but before we do that, we have to first draw out the diagram. So in order to do that, I'll do that now. Now with this problem, because the alternative hypothesis states that it's either positive or negative, this means that it's an and or. And then, so this means that it's going to be a two-tailed test. So I'll draw it on both ends. This is our significance level, but I have to split this up into 2. So now it becomes 0.025 on this end, and then it's going to be 0.025 on the other end. And then I'll take you to the Z chart, and we can show you how we calculate the critical value. Okay, so now we're going to find the critical value associated with the number that I drew earlier on the diagram. So the number that I drew when I split it into a two-tailed test was 0.025. So I'm going to find the critical value that's associated with this number. So in order to do that, I'll slide my finger all the way to the left. So 1.9. So now I need to find the next number. So it's 1.9. This is 0, 1.90, 1.91, 2, 3, 4, 5, and 6. So this means that the critical value for this number is 1.96. So now we'll head back to the diagram to finish the problem. Okay, so now we're back, and as we saw on the chart earlier, that the critical value associated with this is going to be 1.96. So on my left side, I'll make it a negative 1.96. And then on the right side, it's 1.96. Okay, so we just got done finding our critical values. So that was number 3. So the critical value is 1.96. So we'll move over here and we're going to do number 4, which is finding our test statistic, but we're going to do it for a Z. So now the equation for a Z statistic is equal to our observed minus the, let me write this a little bit lower, minus the mean of the actual null hypothesis, all over sigma divided by square root of n being our sample size. So let's write here what's been given to us. So I have n. N has been given already in the equation because n, the sample size is 30 as stated in the equation. So we'll put n equals 30. Sigma has also been given to us, which is the standard deviation. And so with a standard deviation of 15, so I'll underline this. So I'll write that equal to sigma over here. And then lastly, we'll fill in the blank for these two. So our observed is 140 because this is what we observed when we took our sample. So we observed 140 as the mean for the glucose level. So I'll put 140 here. And then lastly, the null hypothesis mean was equal to 100, which I'll underline here, as also stated in the equation. So I'll put mu of the null equals 100. So now we'll just fill in the blanks. So now z equals 140 minus 100 all over 15 divided by the square root of 30. So now we're going to solve for this. So then we go down here. This equals 40 all over 15 square root 30, which just ends up equaling 14.6059. So this is our z statistic. Okay, so to finish off this problem, we're going to do step number 5, which is our last step, which is drawing our conclusion. So because the critical value is 1.96, and we have a z statistic which is larger than that, so because 14, we'll just round this off to 14.6 is larger than our CV of 1.96, we can reject the null hypothesis. So this is our conclusion, so I'll label this as number 5. So this is our conclusion to this z-test statistic.
Hi, my name is Heaven, and today I'll be showing you how to calculate a t-test. So following those same examples from earlier, we're going to be following the hypothesis testing steps. So our equation today is the average American gets a 30 on a math test. You want to know if UCI students do better than the average American. We're going to do a one-tailed test where the alternative hypothesis is mu is greater than 30. Our alpha is going to be 0.05, and we're going to be collecting a sample of 5 people. So their scores are 44, 32, 36, 52, and 36. So we're going to calculate the t-statistic, state the critical value, and then we're going to conclude about our null hypothesis, and then we're going to be stating what this means concerning, so we're going to be starting with step 1, which is to state our null and alternative hypothesis. So according to this, our alternative hypothesis is that mu is greater than 30. And our null hypothesis is that mu is equal. And so we're going to move on to number 2, which is choose our level of significance, which is our alpha is equal to 0.05. So on to step 3, we're going to be finding our critical value, and since we're only doing a one-tailed test, we're going to be focusing on one side of the bell curve. And then so as stated in the equation, our alpha is equal to 0.05. And then since we're doing a t-test, we're going to be focusing on the degrees of freedom. And then, so the equation for our degrees of freedom equals our sample size, which is n, minus 1. So our sample size is 5, so we're going to do 5 minus 1, which is 4. And then we're going to go to our t-table and then look at our critical value for our bill. Since we're focusing on a one-tailed test, we're going to look for our alpha, which is 0.05. And then we're going to go down to degrees of freedom, which is on this side of the column. We're going to look for 4, and then we're going to go all the way across and look for 0.5 in the 4th column, which is 2.132. So regarding step 4, we calculated the mean for our sample size and got 40. And then so we're going to take our sample size and subtract it from the mean. It's going to be xi minus the mean. So we got 4, -8, -4, 12, and -4. So we're going to take that and then we're going to square it. So it's going to be 16, 64, 16, 144, 16. And we're going to add that up and we got 256. So now since we're doing a t-test, we're going to have to calculate sigma. So for sigma, it's going to be the sum of squares divided by n minus 1, which is our degrees of freedom. So we're going to take this equation and do sum of squares equals, what we got is 256 over our degrees of freedom, which is 4. And then we're going to square root it. And then we're going to put that in our calculator and find what that is. So that's going to be equal to 8 for our sigma. So for going based off our t statistic, we're going to be using the equation what we observed minus what we expect over our sigma hat divided by the square root of our sample size. So you're going to plug in what we got so far from our table. What we observed was 40 minus what we expect, which is 30, divided by 8, what we got from our equation from our sigma hat, divided by the square root of our sample size. So we get 10 divided by 3.577, and then we get 2.75. 2.5759. Okay, so to make a correction, the t statistic is 2.795. So we're going to move on to step 5, which is drawing our conclusion. And then since our t statistic is actually larger than our critical value, which is 2.132, so we're actually going to be, our t is in this proportion, which is way out of our bell curve, 2.795, which is way out of our bell curve. We're going to be rejecting the null. Because on this side, you reject the null hypothesis, and if it's within our bell curve, you're going to be failing to reject the null. So our conclusion is that we reject the null hypothesis. And then for what we state concerning UCI students is the fact that UCI students do better on math tests than the average American.